On this video, we will be reviewing over how to solve limiting reactant problems. So what exactly is a limiting reactant? Well, let's go over the following example. Let's say that you're making a grilled cheese sandwich. And to make the grilled cheese sandwich, one needs 1 slice of cheese and 2 pieces of bread to make one sandwich. You look and you have the following supplies. You have 5 slices of cheese and 8 slices of bread. How many sandwiches can you make? Well, if we look at this, we could make 4 complete sandwiches and we would have 1 slice of cheese left over. So, since we ran out of bread first, bread would be our limiting reactant and our cheese would be our excess, since we had extra cheese left over. Now, bread determined how many sandwiches we could make, since bread was the one that we ran out of first. So to solve limiting problems, we will use our limiting substance to determine how much product can be made. So once again, in a chemical reaction, the limiting reactant is the reactant that controls the amount of product you can make. The limiting reactant is used up before the other reactants. The other reactants that are present are the excess reactants. So how do we solve these problems? Well, you will first be given a balanced chemical equation and the amount of the 2 reactants. And you must first determine which reactant you will run out of first. This requires doing a mole-mole problem. So, if we were to look at an example and we were to take 2H2 plus O2 yields 2H2O. And we had 4 moles of H2 and we had 6 moles of O2. Which one of these is our limiting? Well, let's start off with our 4 moles of H2. We'll do a mole-mole between our reactants. We have 1 mole of O2 because our coefficient for oxygen was 1. We have 2 moles of H2 because our coefficient was 2. Notice that moles of H2 cancel out. We are in moles of O2, and we would need 2 moles of O2 to do the reaction. Now this is what we need, and this is what we have. We have more than enough oxygen, therefore our H2 would be our limiting. So let's continue to look at that problem. We had our 2H2 plus O2 yields 2H2O. We had 4 moles and we had 6 moles. Well, let's do our mole-mole problem one more time, starting off with oxygen as chemical A. And we have 6 moles of O2. We have our coefficient of O2 as being 1. We have 2 moles of H2 with that coefficient. And we would need 12 moles of H2 needed. We have 4 moles. Therefore, H2 is the limiting. Now to find out how much H2O is formed, we will take our limiting as chemical A, so 4 moles of H2. We will do our mole-mole between our H2 and our H2O. We have 2 moles of H2O, 2 moles of H2. We do the math, and we have 4 moles of H2O that would be formed. Now let's look at a mass limiting reactant problem. how much molten iron is formed from the reaction of 25 grams of FeO, which is iron 2 oxide, and 25 grams of Al, or aluminum. Now notice that we have our balanced chemical equation right here. And so let's first do a mass problem with FeO being chemical A and then iron being chemical B. So we have our given mass of iron 2 oxide. We have 1 mole of iron 2 oxide over the mass of iron 2 oxide from the periodic table. Notice that we are using our coefficients from our balanced equation. Then we have the mass of iron over 1 mole. Now this right here is just using the equation from mass problems, and you can get that from either the PowerPoints, your notes, or watch the video on mass. Notice that our units cancel out, and we would have an answer of 19.4 grams if iron 2 oxide is limiting. But what if aluminum is the limiting? Well, let's look at that. 25 grams of aluminum, 1 mole of aluminum over the mass of aluminum from the periodic table. Doing our coefficients, we have the mass of iron over 1 mole. Again, this is the equation for a mass problem. So if aluminum is the limiting, we would form 77.6 grams of iron. Let's look at our results. Okay, if we had 25 grams of iron oxide, it can produce 19.4 grams of iron. 25 grams of aluminum can produce 77.6 grams of iron. As we look at these numbers, we can see that iron oxide is the limiting, and we would have excess aluminum present. We can also look at limiting problems with regards to volume. In other words, where liters are a factor as opposed to grams. So here we have an example using a volume limiting reactant. How many liters of NO2 gas can be produced from 5 liters of NO gas and 5 liters of O2 gas? These problems require mole calculations. So we will start off with 5 liters of NO and use that as chemical A, and we will use NO2 as chemical B. Notice we have our balanced chemical equation. 5 liters of NO, we have our coefficients, and 5 liters of NO would produce 5 liters of NO2. Now let's look at this with regards to O2 being our limiting. And we start off with 5 liters of O2 as chemical A, and we will have NO2 as chemical B. So we have our 5 liters of O2. Again, we will do our mole-mole ratio using our coefficients, and we would have 10 liters of NO2 formed if we have 5 liters of O2. Therefore, if we compare these, we would see that NO is our limiting with oxygen having excess.